Electrically charged membrane is porous in structure, also referred as ion exchange membrane. It can be dense or microporous, but most commonly are very finely microporous, with the pore walls carrying fixed positively or negatively charged ion. A membrane fixed with positively charged ion is called as an ion exchange membrane because it binds an ion, which is negatively charged ion, in the surrounding fluid. The reverse is true for the cation exchange membrane, also affected by the exclusion of ions of the same charge as the fixed ion on the membrane structure, charge, and concentration of ions in the solution. This membrane used for processing electrolyte solution in electrodialysis. The diffusion potential on a membrane then depends on the charge carried by the ion, membrane permeability for the given ion, and ion concentration on both sides of the membrane.
First, the function is to treat industrial effluent such as seawater and brackish water desalination. Secondly, mass separation, chemical synthesis, and also energy conversion. It is also used for storage processes, chloroalkali electrolysis, for fuel cells, and also traditionally used in dialysis.
The most common example used is potassium ion. The membrane is selectively permeable to potassium ion. When the membrane is more permeable to potassium ion than other ion, it will make the potassium ion channel than any other type, and the cell is more negative inside than outside. From the picture, it shows that these positively charged ions can diffuse down the concentration gradient to the outside of the cell, leaving behind uncompensated negative charge. So from this picture, it shows that some propionate ion has been separated from a chloride ion through the electrically charged membrane.
Another example for electrically charged membrane, which is electrodialysis. Electrodialysis have ion are transported through semi-permeable membrane under the influence of an electric potential. The membrane are cation or anion selective, which is either positive ion or negative ion will flow through. Cation selective membrane are polyelectrolyte with negatively charged metal, which rejects negatively charged ion and allow positively charged ion to flow through. By placing multiple membrane in a row, which alternately allow positively or negatively charged ion to flow through, this technique can be applied to remove ions from water. Electrodialysis is very useful for water treatment, aiding in the removal of mineral salts, sulfate, nitrate, and others from brackish water and seawater. Electrodialysis is also useful for wastewater reduction or recovery. This is the example figure for electrodialysis system.